So today we'll be doing another Codeforces contest. I'm certainly very late, and this is Codeforces round 771. Okay, let's create our template. So first we input the test cases. I've read the problem A. Um, okay, so we are given a permutation, so you just have to reverse a part of that permutation, that is from L to R. So first line, so you are given a permutation. To store the permutation, you can take a vector int p, and we can actually give it the length, and for int I is 0, I less than n, I plus, and we can actually create another permutation called a, and yeah, you will see why. So first we see in p of I, and we say that a of I is equals to I, or maybe I plus 1, right? So the smallest permutation of numbers 1 to n is basically 1, 2, 3, 4, 5, and so on up till n, right? So what I think is that wherever the permutation is different from a of I, that is the ideal permutation, that is the smallest permutation there can be. Wherever it is different, we'll have to start the reversal from that location, right? So that will be RL, right? And where will we go? So we will actually go up till we find the number that was supposed to be here, right? So what I'll do is, if P of I is not equals to A of I, then what we do is we go and find A of I in the P of I array. And how will we do that? Create another loop, maybe, and j is equal to 0 and j less than n, j plus plus, and I can maybe create an answer array. So vector in answer, and this is n comma 0. So if P of I is equals A of I, then we can just store it in the answer of I, right? And if it's not, then what do we do is basically if this is not, then we actually first we find the value where A of I occurs. So j will be from I plus 1 up till less than n, right? And j plus plus. So if P of j is equals A of I, then that means we have found the number, right? That was supposed to be there, and so that becomes our R. So R is equals to j. So where do I declare L is equals to I, and int R is equals to, so let's say -1, R is equals to j, and yeah, and then after we have found it, we just break out of this loop, and we also break out of this loop because we no longer need this. So actually we will need this L and R, so let's just declare it outside this stuff. So I'm just going to do that. So let's declare it here, and So after this has been done, then what do we have to do is basically for reverse the L to R, right? So we can do that using reverse operation maybe. Um, that would be answer of, so that would be P of P dot begin uh, hmm, plus L maybe. Oh, now I feel that I should have taken like a P array with that N so that I can add L here conveniently, and up till P dot begin plus, what I can do is I can actually run this function and actually keep on reversing until I get there. Let's just use this function, and so this plus R, and I think this will reverse it, so this would be P and P plus L plus R, and I just gotta display it now. Yeah, fine. Let's copy it. So what if we never find a J? Then we'll just get an answer as this, right? Declaration of P. Okay, now we'll have to remove this from here and int P of N. Yeah, that seems good. So we don't even need the answer array now, and we can actually ignore all of this also, right? And oh no, it's wrong. It's coming out to be wrong. Why is that happening? Oh wow, this is correct, but this is not. So for I equals 0, so if P of I is not equals to P of I, that will be true for the first test case, and we found it here. So R should be equals to J, right? And we should reverse it. This should reverse it, right? Okay, this should be R. Let's see. Oh no. Oh shit. Is this not happening? This one maybe? Yeah, this should work, right? Because this R is not included. I'm scared to submit. Should I submit? Because I did not intend to participate in this contest, but let it be. So let's read the other problems. Okay. Oh, chap, sort. You can perform the following operations in each array. Swap elements A of I and AI plus 1 if AI plus 1 is odd codingblocks.com, and yeah, the period is passed. Okay, so we are given some conditions. Is it like bubble sort? Because we are swapping the elements, but there is an extra condition. Can we just implement bubble sort? Can I? So what I can do is I can implement bubble sort, maybe, because the constraints are is by 5. Okay, so let it be t cnt while t minus minus int n cnn, store it in a vector. So what I'm gonna do is write O of n square solution. We can actually did I just forget bubble sort? Oh. If a of j is greater than a of j plus 1, this is the condition for swap. So basically we swap a of j comma a of j plus 1, right? Can I do with a vector? I think I can do it with a vector, and we just have to add another functionality, and that is that ai and ai plus 1 should be odd, so aj, and since it is going to j plus 1, then this should be n minus 1 maybe. Did I just forget bubble sort? Okay, so a of j plus a of j plus 1, this when modded by 2 should give us 1, right? Only then can we swap, and we can say that flag is equals to 0, and we can say that and flag equals 0, and we can say here flag is 1, and if after this loop if flag turns out to be 0, if flag is 0, then we can say that we cannot perform, we can say that cout less than no, and we can break here, and if we want we can actually take a global flag also. Gf equals 0 gf equals false, so if here I can say that gf equals true, and if gf is equals false, then we can say that it did not print no, so we are gonna print yes. I think this might work. Let's see. Let me look up bubbles sort. Am I missing something? So it goes from n minus I minus 1. Okay, that was the thing I was looking for. Vector was not declared. Amazing. I should not even use vector, by the way. minus 1, and we swap if this is, yeah, so rest part is fine, and this should go up to n minus 1 for sure. And we can, yeah, I think we can use vector, right? Yes, no, no, yes, oh no, I was just printing out 3 no's or 4 no's. Okay, it's not printing out yes anywhere. So okay, there might be an iteration where they are actually like so what I need to take care of is that they actually might just be sorted, right? So they might have been sorted already, but this should produce a still a yes, right here, because of uh, hmm. So I just need to take care of the fact that if this is not letting us do this, then I should make the flag 1. Basically, and this is if this is not equals to 1, right? So basically this is equals to 0. This means that we have fucked up and flag should be equals to 0, and we break. Since we need to swap, but this condition doesn't let us do that, right? And if we are not swapping because of this condition, then we do not turn flag to be wait a second, how am I gonna handle that? How am I gonna handle that? So int flag 1, flag 2 maybe, so 0, this is 1, so fl2 is equal to 0, and we break. So if fl2 is equals to 0, only then we so if there were swaps to be made, but because of this condition it did not happen, then we can say no. And yeah, I think this might work. Then we don't even need this flag maybe, right? So I think this should work. Let's see. Percentage token. What? If this is an integer, right? So yes, no, no, yes. I think this might work. It is highly complex though, so time complexity might exceed, but you gotta take the risk. So looking at the next problem, Gaussian graph, you are given a permutation, then an undirected graph is constructed in the following. Oh no, a graph function, a graph question. Shit, we fucked up. So we have officially fucked up, and we can no longer solve this. Okay, I was hoping for a time limit exceeded, but this was some next level shit. And since it is a wrong answer, that means our logic is wrong. That should not be the case. Let's see the bubble sort. So J starts from 0. Oh no. This is bullshit. I am so bad at this. Imagine if it gives me TLE now. Oh no. Wait a second. Of course, it should be from 0, right? What was I thinking? Okay. Let me see that. So we need to get some graphs and we need to check connected components in this graph. So count number of connected components in a graph. And undirected. Is it undirected? Yeah, it is undirected. So we can use this function, this program maybe. Okay, so that's a good thing that we are able to use pre-made code, and there is only one code on this website, and there are not like tens of codes that actually. Oh, our pretest pass. Nice. Okay. Let's make another blogs.com. So we have a add edge functionality, and okay, so what we need to do is int right, test cases, and then we have an n that will be the length of the permutation and will also be the nodes in the graph. So we will give it an n, right? And we are not given which edges. So it is a permutation. What? Oh, okay. And does this code edges start from 0? Sure, they start from 0. What do I do to make them start from 1? How do I change it? How do I change it? So inversions in an array. We don't have to count inversions, we have to make an edge on every inversion. So what should we use? Can you please close the door? Should we use merge sort or what? simple approach. You don't like simple approaches? Enhance, merge, sort. Oh no, this is complex. Oh no, oh no. Heap sort plus bisection. That sounds interesting. But how can I get the inversions? I think the simple method is readable by me, and I think I can copy paste this. So what I'll do is actually this is simple implementation brute force, and what I'm gonna do is take a vector int of a of n comma 0 and basically traverse this vector. Oh no, why do they not add this shit? And if this happens, then I'm just gonna add edge between. So in this graph we start from 0. So let's add an edge between a r r I minus 1 and a r r j minus 1, right? So after doing that, we can actually display the number of connected components, I guess. Simple brute force approach I have tried. This might not work. Oh, we forgot to copy the input. An array was not declared. Okay. Zero. Zero connected components. That's painful. So why is that happening? Now I can't even guess what is the reason. Because I haven't implemented this nor this. So basically it goes over every pair that is of the sort where I is less than j, and basically check if a of I is greater than aj, then we make an edge between a of I and aj, and we can actually print the number of connected components. Right, let's try this. Maybe something goes wrong that time. Still 0. Why is that happening? Let's add some brackets maybe. That should not be a problem, but okay. Why is it showing 0? At least 1 should be there, right? 0. 0 all the way. Oh, we haven't inputted in. What am I doing with my life? And I haven't even inputted the vector and 331121. Okay. Let's read the problem D. Big brush, colorful operations, two posters. So big brush, you found a painting on a canvas of size n cross m. The canvas can be represented as a grid with n rows. Shit. Oh no. Hmm. Found a brush in the shape of a 2 cross 2 square, so the canvas was surely painted in the following way. No cell was painted in the following paint operation performed some number of times. I think I'm gonna skip this contest now. I think it's time for me to quit. So this talks about a canvas and each cell has some color and there is a brush of 2 cross 2 square. So initially no cell was painted, following painting operation was performed. So this operation is like ij, choose any I and j and some color k, and we paint the cells. This is because we have a 2 plus 2 brush, right? So ij and then I plus 1j and I and j plus 1 and then both. So basically ij is the top left of that square. All cell must be painted at least once. Cell can be painted multiple times. So maybe I have to reduce this over n square complexity. All cell must be painted at least once. In this case, its final color will be last one. Find any sequence of at most nm operations that could have led to the painting you found, or state that it's impossible. So I think it is impossible when the last the corner four squares have a different paint, right? They have to be of the same color. The last corner squares, like these corner squares. I think in the first test case, the solution is not unique. Here's one of them. Okay, in the first test case, there is a valid. So it brushes here, he brushes here. Oh no, we can make these four of a different color. My bad. So what do we do then? Then we do this, then we do this, then we do this, and then we do this. So 4, 5, and 6. So what is this? So this is the final. Nice. And there is a -1. How could that be? Let's see. So it's like, what is the input? I and j, and then what is this? Okay. So input is basically the color of the cell. Okay. So for this is 3 cross 4, and we are basically coloring the first color, first whole rows of first one color, then this is 2 and 3 and then 1 1 1. So how could they have put a 3 here? By basically putting here, maybe after this 1 1. Yeah, I think this is possible, isn't it? No, it's not. It's not possible because like to put these ones, like these ones here, you have to paint this block with ones, right? So this 3 has to go kind of like that. So what I can see is like they always appear in 2 or more. No single color can appear there. Yeah. So it's like no no box should be there which has no color adjacent as same maybe. But let's say we have colors like 111 and 22. So so I'm just trying to make a single what do you call it, pixel or what, single block to be a single of unique color. So let's say this is 3. This can't be 3 because all of these need to be 2, right? And when these were colored to be 2, then this would have been removed. But let's say this is like a large one and we actually put 3 in the middle. Um, so we can actually paint this 2 using another 2, and this, yeah, this can happen, right? So for these two we can actually have a 2 here, 2 here, and a 2 here. So these two are included in this square, these two are included in this square, and so we can actually achieve this. So not one here, so one cannot be here, or can it be? I think then this 2 can't be here, or can this 2 be here also? Yeah, so first we paint this square to be 2, and then yeah, we can't get a 1 here, so this is impossible. So let's make it 2. Yeah, so this is possible completely or not? No, this is not possible because of this 2, right? Because how did we paint this 2 then? Maybe we've painted a 2 square right here, and then we painted a 3 right here. Yeah, this is possible then. And this is possible. So D is out of our range. So let's just try and reduce our time complexity in C, and yeah, we'll have to understand what this function is doing, kind of. Hmm. Let's see, print inversions of array. Oh no, there is no help out there. This is O of n square. Merge that print inversion. Okay, so we take I and j and index to be 1. What is this? Array merged 1 n plus n. While I is less than this, merge this, merge this. What is going on? It would have been lovely if you would have provided solutions to that. If you want to print all pairs of inversions as answer by system, Nothing fancy like what's satisfied. However, if you just want to count all inversions, uh-huh. So, so what is the complexity causing disease here? Can we even print the inversions in O of like less than O of n square? Can we do that? So this is done. This is, I think I'm not even able to figure out the reason why some things should not happen. Like this. So basically, what I'm able to think of is if you think of this as a graph, then this graph should, every node of this graph should only touch like two different colors and not more than two different colors. If it touches three different colors, then it produce a -1. But even after that, how will I find the painting operations? And do we have to find the minimum number of operations? At most of nm operations. So, oh, okay, nm, that gives us a hint. What hint does it give? It The hint that it gives us basically we can start from the first and then we move on for every different, like first we make this square and then based on the color of this and color of this we can choose this square and then this square, right? Kind of like that. So since I don't even know graphs right now, I can implement it without a graph also. Let me see. I really need to learn graphs though. So that is one problem. Let's just remove this. Let's just remove this also. But then that means that we can have four colors, three different colors on a single guy, right? Like this can be yellow, this can be green, this can be blue, and then this can be something else because of this square, right? So my logic is wrong, basically. गहरा So this is, I think, out of reach then. But let's just keep it open. So you have an array. Each element initially has a value 0 and a color 1. You're also given Q queries. And what is this? 2 posters. You want to advertise your new business, so you're going to place 2 new posters on a billboard. Pre-test 3. Oh. We still have 1 hour though, but I don't wanna spend too much time on this. So number of connected components is like O of n, right? And the reason This failing is probably because of this. Hmm. So since it is a permutation, since it is a permutation, that means what we can do is count comma 0 and so this should have at most n elements, so we need plus 1. What I can say is create a prefix matrix, but that would still be required for like uh, so for count we can say let's take a vector. Hmm. Can we create a map or like a set um, set s and then uh, so for every number we traverse the set. Hmm. But this might not reduce the time complexity. Will it? Will it or will it not? This will not. Hmm. So suppose the number of inversions in the left half and the right half of the array be inversion 1, and what kind of inversions are not counted for an inversion plus inversion? So it is the inversion that need to be counted during the merge step. Therefore, to get the total number of inversions that needs to be added are the number of inversions in the left subarray and the right subarray and merge. So how to get the number of merge postulate? I is used for indexing left subarray and j is for right subarray. At any step merge, if a of I is greater than a of j, then there are Right, minus I inversions. Oh no. I get it. If AFI is greater than HA, uh-huh, mid minus I inversions. So this is purely relating to the count, right? How will I find which of those elements is actually? I think it has something to do with the permutation thing. So I think what I can do is, since let's say 6 comes right here, and it should have been after 1, 2, 3, 4, and 5. So supposedly it should be the have an edge with 1, 2, 3, 4, 5, right? So this is my theory. So yeah, so I'm gonna do that. Um, that can be done in using a set, or can actually ditch the set. What I can do is basically for n I is equals to 1, I less than n, or a of I, and I plus plus. What I can do is basically dot add edge between I and a of I, right? I think this might work. This might just work. The only problem is it starts with 0, so I will have to use 0 here, and a minus 1, and a minus 1 should be added with, yeah, I, right? Hmm. Does this work? Does this work? Am I a fucking uh, but the only problem is that is adding a edge taking a large complexity? I don't think like this is still n square, right? Or is it not? It is so like for 6 we at most have to add n edges to it, right? So yeah, that's the problem. And wait a second, uh, we only have to add 0 to that element if they have not been done yet. So my using offset was correct or no? So basically n I is equal to 0, I less than n plus plus, and s dot insert I, and we, after every a of I being added, we have to remove element from set C++. Please don't take a lot of what is the method, bro? Just tell me the method. Erase. Oh, there is no default function for that. So what else can we use if we don't have, like, we can use mhm. All what I can do is basically make the set empty and s dot insert AFI. So what I can do is and I is equal to 0, I less than AFI that we did here, right? And we can just check that if so we can add a -1. So if s dot find, I hope this is the function, set stl. Why do I always have to look up this? Yeah, I can use count maybe, and what I can do is s dot count of basically the j. If this is found in the set, that means this has already been occurred, so we won't do this. So 0, if it's 0 then we add an h, that means it has not yet come, and obviously it will come after it, right? And yeah, that is the solution according to me. So I think this might work. Oh, I have to remove this shit. Segmentation fault. Weird. Oh. Okay. Imagine if this still not decreases my complexity. Come on. What? Okay, so this might be a -1. Okay, 3 3 1 1 2 1. So the only problem is what if this still not decreases the time complexity? Then what? That's the question. I hope this does. If it's not, I'm just leaving. GG's. Nice contest. Bye bye. Let's just check. This question, I don't know what to do on this one. I can't even figure out that what is the condition for the negative one. Shit. Still the time limit exceeded. Is the problem inside like okay. So it should finish in 1 second. I don't know. This is what I could come up with in versions in permutation. Hmm. Let's see this. So you are given an array on modified AVL tree bit. I just don't have to find the count, please. I have to find. Initialize a variable answer as 0 to store the number of inversions in the array. Uh, iterate in the range, store the index of occurrence of array of I vector. Add the count of numbers having position less than the index that are present in the vector. Since they are smaller than the current element, thus form inversions. I think BIT is what we need here, but the only problem being again. So I think I'm solving two different problems, and like first I'm finding the inversions and then printing out the connected components, right? What if there is a way in which I can print the connected components directly? Uh, yeah, there must be a way, right? So yeah, so we might not even need a graph, right? So what that way can be is basically so if we are adding an edge, that means they are a component, and what can I do? Mm, can I do? But checking the connected components is like it's like O of n, right? So that should not be V plus E. That's like O of n, right? It's like 2n or 3n, right? I don't know. Maybe edges are like n square times. Maybe that might be the issue. Ah, so 2 comes here. Hmm. 6 comes here. 6 is associated with 1, 2, 3. 4 comes right here and it's associated with 2 and then associated with 6 also. 3 also. In like in a perfect permutation like 1 2 3, the connected components is 0 3, right? The number of, so basically the connected components are n if no inversions, right? If there are, let's say, one inversion is there, then they too might. Hmm. hmm. If two inversions, then we can't say, right? Because that too can be from the same element. So in that case, there are still two connected components, and if they are with different elements, then um, okay. So if I have to ditch the graph, then what I can do is make a vector and store basically the color, right? But still, that would be of the same complexity now. That is the problem. Like I can take an n plus 1 graph and um, um, or same graph, and what I can do is initialize it with a color of, let's say, -1 or let's say 0, and we what we can do is whenever we find out this, instead of adding an edge, uh, we just check if there is already a color, that is that basically check that color of j, j, right, is if color of j is not equals to let's say the current color that is going on, current color, then that means it was already a part of some component. But how would that reduce our time complexity? I don't get that. Basically, if color of j is not equals to 0, that was the default color. That means it was actually connected to some component before, right? So now all of them become that color. Mm, 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 mm. So we say that flag is equals to true, and we take a flag here, flag equals false. So if it's false, that means it is actually increasing the number of components, and if uh, uh, so so we are actually gonna change the color of j to be equal to the current color we are having, and then we can actually say the current color plus plus, and if we can only do this if the flag is like true. So if flag is false, right, if flag is false, we say that current color plus plus, and yeah, then we can just display cout less than current color handle, right, because and the current color should start from 1. But still we are using a set, right? Oh no, this is producing a wrong answer. Why is that? So if flag is false, then we actually created a new component, right? Like in this one? Haven't we? Oh, but what if that later merges with some other component? Fuck. Totally forgot about that one. Hmm. 3 goes in this, and 3 goes with 2. Then 5 comes, 5 goes with 2, and 5 goes with 4. Boom. No, this won't happen, right? But this might happen. 6 goes to 5. But if this happens, that means if if like this happens, that means this would have already happened. So what I'm saying is, so if 4 goes to 3, and then 3 actually goes to 1, right? But we already know that 4 is already going to every other number that is smaller than it, even 1, right? So if 4 is actually going to every other smaller number, then for every other smaller number, uh, can we say that for every other smaller number we have already created the graph, like added the edges of for that guy, right? Can we say that? Yes, we can say that. So for every other smaller number we don't do anything. But how would that uh, how do I implement that? So what I'm saying is that we are still gonna use the graph. See, that is why I comment things, and instead of like current color and stuff like that, we are still gonna, I don't know why this color one did not work. Yeah, so we're just gonna take this, and when we are doing this we are actually gonna ignore the every element that is lower than that after, and that comes after it. So can I create another set for that? Set int is2, and should I create another set for it, or I should create a vector? I should create a vector. So vector int, and basically do array dot array, maybe do for this array, and it should have n and this. So basically what I'm gonna do is, uh, since I'm adding an edge, and then I'll have to remove, basically do for of that number j would now be equals to true, right? So this was false, and if it's true then we don't do this function. If it's false, we do it. So if do for of if I is equals false, that means we haven't done this guy. Now this might reduce time complexity, but I don't know. Um, I think every number from 1 to 4 should be done, because either it has become come before it, but then we won't add edge to it, right? So to add, for adding an edge, we will have to see that it has not occurred inside this. So yeah, so this should happen. This is correct. 33121. What? 33121, right? So this works, but is it like the ultimate smallest complexity? Like, we are actually reducing the complexity for sure, but is it enough? If I don't do this, I'm just gonna end this if this doesn't work, because I'm just gonna watch the tutorial tomorrow and just do it. Yeah, fuck this. Come on, come on, come on, come on. Please, please don't, please don't, please don't. Oh no. Bye, guys. Thank you for watching. It has been a great stream. Thank you. Um, Sorry for not able to find the solution, but I'm sure you can find it tomorrow easily. See ya.